Morning, everybody. I want to spend a little bit of time today going over how we're going to name ionic compounds that have transition metals in them. Remember, transition metals plus a couple others, tin and lead, they have variable charges. So we have to make sure that we indicate that when we name them using Roman numerals. Remember, the Roman numerals, if we're writing formulas, the Roman numeral represents the charge on that transition metal in that circumstance. So don't overthink that. If it is a Roman numeral 2, it means that that has a +2 charge. Roman numeral 3, a +3 charge. When we're going the opposite way, though, and we have to actually name them, then it becomes a little bit more complicated, but not really. So let's just do an example here. We have cobalt and we have bromine. So we know that this is going to be cobalt bromide. But the problem is that if you take a look at your periodic table, cobalt is a transition metal. So we have to make sure that we name it and we use a Roman numeral. Okay. Now here's what I like to do. We just remember this is an ionic compound. So we're going to have a positive side and we're going to have a negative side. All right. This is the cation. This is the anion. So what we do is we kind of work backwards. We need to figure out what the charge is on cobalt in this situation. So let's work with what we know. We know that bromine has a -1 charge. I know that from the periodic table. And that's per atom. Well, we have 2 atoms. So 2, each of them has a -1 charge. That means that overall we have a -2 charge on our anion side. Okay? So when we're doing those problems, especially the back side of the worksheet that you have, that's the first step. Figure out what the overall, how many electrons are accepted on the anion side. Next thing you want to do then is just take this number and we're going to put it over here, but we're going to change the sign. And what that means is this cation side has to give up 2 electrons because these numbers have to cancel each other out. Okay? Well, cobalt, there isn't a 1 there. Okay, we never write a subscript 1, but it is implied. So I'm going to put a 1 there just so we understand that. Well, here's the thing then. 1 times what gives us 2? Well, I mean, that's pretty easy math. 1 times a +2 gives us a +2. So in this case, cobalt has a +2 charge. So we would write this as cobalt 2 bromide. Oops, sorry, it's early. Cobalt 2 bromide. Okay, that 2 represents the +2 there. All right, let's do another one. We have silver and we have phosphorus. So this is going to be silver phosphide, but we need to make sure that we indicate what silver is in this case. Okay, so same thing. You don't have to put a line there. I'm just doing it to show you. This is our positive side. This is our positive side. This is our negative side. Phosphorus has a charge of -3. There's only 1 of them. So our overall charge is a -3, which means over here, just put +3. There are 3 silver atoms. What charge does each one have to have in order to give us a +3? Well, 3 times +1 gives us +3. So this would be silver. There's a 1 there. 1 phosphide. Oops, I'm running off my page here. There we go. Silver 1. That Roman numeral 1 refers to that +1 there. And again, you guys just figure out what our negative charge is, put that number over here, but flip the sign, and then just figure out what's missing right here. Okay. Now, what happens if we have a polyatomic ion? All right, so we have PbSO4. Well, remember, whenever we're dealing with polyatomic ions, ignore this subscript right here. This SO4 sulfate functions as just 1 unit. These atoms are covalently bonded, but they function as 1. And again, just to review, we know that these are ionic compounds because the first element is a metal. All right, and that indicates that this is an ionic compound. So here's the thing. I'm going to put my line here again. And again, you don't have to do that. I'm just doing that to show. Okay, sulfate has a -2 charge. All right, and we know that because on the list of polyatomic ions I gave you, that's the charge that it has. Okay, now you're going to be tempted to want to go 4 times a -2, but don't, because remember this 4, we're just ignoring that. There is only one sulfate ion. This thing operates as if it was one unit. So there's only one of them. So 1 times a -2 gives us an overall charge of a -2. Don't worry about that 4. Don't multiply that times the charge. Okay? So that means that we have to have a +2 over here as an overall charge. We have 1 lead. Okay, so 1 times a +2 gives us +2. So we would then call this one lead 2 sulfate. Okay, and again, that Roman numeral 2 represents that +2 charge right there. Okay, so you guys try not to overthink this. Use the examples that I just gave you. Use the examples from the other videos that I gave you, and try your best. Get the ones done on the back side of that page. Remember, all we're looking is for this number right here. Follow these steps and you should be okay. Tomorrow's Thursday. First thing we'll do is we're going to go over this worksheet. And then the last thing we have to do for naming compounds is how do we name molecules? And that's where we work in prefixes. Okay? Do your best today, and I will see everybody tomorrow at school. Have a great day, you guys. Bye-bye.